Welcome back to another metrology and measurements session. This subject is about ME.P.NAVIN metrology and measurements. My name is P.NAVIN JASS, Assistant Professor, Rohini College of Engineering and Technology, Department of Mechanical Engineering. Advances in metrology.
Okay, then types and uses of laser interferometer. The main thing is types of laser interferometer. There are two different types of laser interferometer. One is AC laser interferometer, another one is DC laser interferometer. So first one, DC laser interferometer. So in this DC laser interferometer, there's a laser light source. For the main parts of the DC laser interferometer, there's a laser light source. This laser light source which produces the polarized beam, and here there's a fixed retroreflector and a moving retroreflector, and there's a reference arm. There's a beam splitter is there, which is used to split the single beam into two beams, and there's a recombined beam is also there, and there's a quarter wave plate and deflectors and receiver. These are the things occurs in the DC laser interferometer. So here the DC laser interferometer uses a single frequency circular polarized laser beam. This laser source which produces this polarized laser beam, the single frequency laser beam splitted into two components with the help of the beam splitter. One is in a horizontal way and other one is in a vertical way. The reflected beam being vertically polarized light and transmitted beam being horizontal polarized light. Here there's a reflected beam moves in a vertical polarized light and transmitted beam moves in a horizontal polarized light. These two beams are referred as a reference arm and measurement arm. So these two beams are called as a reference arm and a measurement arm. They travel to the retroreflectors and then they are reflected back towards this beam splitter, and these beams are recombined at beam splitter consists of two superimposed beams of different polarization. One component vertically polarized having traveled around reference arm, and another one is horizontally polarized having traveled around the measurement arm. These two beams are differently polarized and they do not interfere. The recombined beam then passes through a quarter wave plate. This recombined beam passes through the quarter wave plate, which causes two beams to interfere with one another to produce a beam of plane polarized light. So here the orientation of the plane of this polarized light depends on the phase difference between light in the two returned beams. The beam after quarter wave plate is split into three polarization sensitive detectors. As the plane polarized light spins, each detector produces sinusoidal output waveform. The polarization sensitivity of the detectors can be set so that the output have relative phases of 0 degree, 90 degree and 180 degree. The output of three detectors can be used to distinguish the difference between the movement and also distance moved by the moving retroreflector attached to the surface whose displacement is to be measured. Okay, for linear measurements, the retroreflector is attached to the body and moving along the linear axis. For angular measurement, angular beam splitter is placed in the path between the laser head and angular reflector and angular reflector. It is possible to measure the flatness, straightness, and rotary axis calibration. So this is the working of the DC laser interferometer. Next one is AC laser interferometer. In this AC laser interferometer, there is a 2 frequency Zeeman laser beam splitter, then fixed internal cube corner and moving internal cube corner or external cube corner, and there is a photo detectors, amplifiers, and pulse converter. So first, what is the use of this 2 frequency Zeeman laser? It is generally a helium neon type laser which generates the stable coherent light beams of 2 frequencies. One is vertically polarized and another one is horizontally polarized related to the plane of the mounting. Then beam splitters. It is divided the laser beam into separate beams along the different axes. One is in a horizontal way and another one is in a vertical way. Then cube corners or retroreflectors. There are 2 different retroreflectors are there. One is a reference retroreflector or moving retroreflector, or we call it as a fixed internal cube corner and external cube corner. So in these cube corners, one is fixed cube corner and another one is a movable cube corner. Both the retroreflectors are used to reflect the laser beam. These retroreflectors reflect light parallel to its angle of incidence regardless of retroreflectors alignment accuracy. Then next one is photodetectors. What is the use of these photodetectors? It is used to receive the signal from the beam splitter and they change it into the electrical signal. Photodetectors captures the beams from the beam splitter or signals from the beam splitter and it changed it into a electrical signal. Then what is the use of the amplifiers? It is used to separate the frequency difference. It is used to separate the frequency difference, or it receives the electrical signals as a low input signals and convert it into a high output signals. What is the use of the pulse converter? It is used to convert, or it is used to extract the change in frequency, which is called as delta F. These are the different parts of the working or usage of these parts of the AC laser interferometer. Okay, now what is the working of this AC laser interferometer? This 2 frequency Zeeman laser which produces the helium neon laser, and this laser beam laser polarized beam which moves to the beam splitter 1 and it splits the signal into 2. One is on a horizontal and other one is on a vertical. This horizontal beam which moves to the second beam splitter. The second beam splitter captures the polarized beam and divides it into or split it into 2. One is on a horizontal way, another one is vertical way. This vertical beam which moves directly to the reference retroreflector and it reflects to the same beam splitter at one point, and the horizontal beam which moves to the moving retroreflector. According to the length of this moving retroreflector, we can find out the distance. So it will retroreflector and reflect it to the same point which collected at the beam splitter, and it directly moves to the photo detector 2. What is the use of this photo detector? It is used to receive the electrical signal. It receives the signals from the beam splitter and it converts it into a electrical signal. So then it moves to the Doppler signal, which we call it as a F2 minus F1 plus or minus delta F, and directly moves to the amplifiers as a low input signal and it converts into a high output signal to the pulse converter. Likewise, from the beam splitter 1, the vertical beam which moves to the photodetector, and it receives the signals into it receives the signal from the beam splitter and convert it into electrical signal, and we got it as a reference signal as F2 minus F1, and it moves as a low input signal to the amplifier and converts into high output signal and moves to the pulse converter, and it extracts the change in frequency as delta F of both the signals. So this is the working of the AC laser interferometer. So what are the different types of AC laser interferometer? There are two different types of AC laser interferometer. One is standard interferometer or single beam interferometer. One is standard interferometer or single beam and single beam interferometer. Standard interferometer. It is also called as a heterodyne interferometer. It produces two close but unequal frequencies. In this interferometer, the displacement is measured between the interferometer and its cube corner. The measurement retroreflector for the interferometer is a cube corner. The standard interferometer for measuring the displacement. It is least expensive and it can be used wherever it is possible. And another one is single beam interferometer. It is also called as homodyne interferometer. It uses single frequency laser beam to obtain measurement. It has the outgoing and returning beam superimposed on each other, and it gives the appearance of only one beam traveling between the interferometer and retroreflector. It is very much suitable when the space for optics and beam path is limited. The interferometer and cube corner for this system are considerably smaller than the standard system. So by this topic, we are concluding this session. Thank you.